So our first shapes are rectangles, or like our basically our regular four-sided shapes we worked with a lot. So we have rectangle, parallelogram, bless you. Now we also in those categories put a rhombus and a square. But we're also going to have a second formula for rhombus. I'm going to put a little star by it so that you remember that if it comes up that it's not a good, the formula is not helping you, then you should try the other formula. So we'll have a rhombus further down the chart as well. So we had two different formulas. Length times width or base times height. It kind of just more like whatever you prefer to call them, or what you've been given. So in a problem, if I tell you the length is this, and here's the area, find the width, you might want to use that formula, but making sure you guys know what those two different things mean. So when we're talking about this, and I'm talking about the details here, what I mean by that is, so like the base and height, remember, have to be perpendicular. So the base is all the way across the bottom and the height is perpendicular. Or we could have length and width. And it doesn't matter which one you call which. But it is important that the base and height are perpendicular and the length and width are perpendicular. Again, if you look back at this and you're like, I don't know what any of that means, then we should be like writing something different. So let me know, like if you have questions, or we can write a little note that if you never remember the word base and height, write that out. So like figure out what works best for you guys so that this is a good tool for you. Now, the next one's not going to be a formula, well, it is a formula, but it's not necessarily having to do with the area. We got into a lot of different information about right triangles. We realized we could use right triangles to help us define the area. So we learned that in a lot of these problems, we don't know all the sides of the shape or whatever we're looking for. So we want to use two different formulas, or two different types of formulas. Bless you. So this one works if we know two sides. A squared plus b squared equals c squared. So if you know two sides of the right triangle, you want to use those. If you don't know two sides, but you know a side and an angle, that's when we use SOHCAHTOA. So there will be some SOHCAHTOA on this test. Not a ton. There's not like every problem. Now remember, this is only for right triangles. So both of these rules only apply to right triangles. So when I say we know a side and an angle, we know it's also a right triangle. If you know two sides, I also know it's a right triangle. So these must be right. Bless you.
Bless you.
Then we have the area of a triangle. And again, we have a couple different formulas for this, either whatever one makes the most sense to you. The big thing with triangles is because the base and height can show up in different places depending on the type of triangle. So if it's a right triangle, But if it's a non-right, the height is probably going through this shape, where the base is across the bottom. And then like an obtuse triangle, this one, the height's completely outside the shape. And if you can't tell what I'm writing there, let me know. I can try to draw a better picture, but we drew these in our notes as well. And the chart's really so that you guys don't have to memorize all these formulas. There's probably a lot of them you probably know pretty well, but it's easy to get them mixed up. And again, like if you're really doing something with area, you possibly would use some sort of like, you might Google something, but like knowing what formulas we can use is obviously helpful. So that's why I don't necessarily need you to memorize them, even though a lot of these, again, you probably know. Now what you do need to know is different shapes, and so you need to know when you see a trapezoid, that's what it is, so you know to use the formula that we have for a trapezoid. Now sometimes with a trapezoid you can break it up and make it a triangle and a rectangle, or a triangle and a parallelogram, but just know that there's also the formulas. Again, whatever one you prefer. I tend to like the ones that have the big division bar in them, like the top ones, but so in our trapezoid here, it's important to know that B1 and B2 are parallel. So those bases are parallel. And then the height is perpendicular to the bases. Our next two are kites and rhombuses. Now I'm going to put a star by rhombus because we already had a formula for rhombus. So this one also works depending on what you know. Now make sure you write this one down correctly. This one's multiply, whereas the last one's add. So they look a lot alike. But this one we're multiplying instead of adding. And remember that the diagonals are perpendicular to each other. So those diagonals are going across the shape. They're a little harder to show the length of because like you're going right through it. So it's how like tall and how wide it is, but that again, that distance in the middle is perpendicular. So we really don't care about the outside edges in a kite at all, or a rhombus, unless we're looking for a perimeter. Why don't we do 2 more boxes here? We'll finish these up and then take a little break. Our break will have to be quiet though. Whisper break. what's the temp? I know, I think it's really cold. I haven't warmed up from yesterday's baseball game. It was so cold. But the dugout I heard was warm because they were blocked by the wind. But like, it was so cold. Like, I feel like, was your soccer, were you so cold? The wind was so bad. I feel like I really rarely complain. How'd the game go? Is Cedar Grove?
Yeah, we were walking for 4 hours.
Yeah.
Actually, it was all
Yeah.
it's all.
Okay.
We're in May.
It's actually pretty low. We were pretty low. We were pretty
Okay.
except for a couple holes that were way up towards the end. Or like the one.
Oh, whoops. Actually, no, I didn't want to do this. Hang on. Don't follow what I have.
Yeah, it was kind of cool, but not the rest of them. Yeah, we're taking cards now. You can't drive a car.
You can.
You need a balanced driving license.
This guy.
No, there's
I don't know if Colchin knew he was going in to run during baseball last night, and he went out there and.
They like really slow.
Well, Luke Colchin I think is fast. Kyle, I would not. Well, he went out to run.
Luke's slower than Kyle.
Well, they were both on the bases together, so there was no way he was going to pass.
Fast as Peyton.
Peyton is very fast. I don't know what you're talking about. Just kidding. He's not. But so Luke went out there to run, and he was wearing a hoodie, like an orange hoodie, so he had to take his hoodie off, and he was like had bare arms, like he looked so cold, like and
Score.
6-1 they ended up winning. We were down 1-0 until the last inning, so they.
No, you can't.
What
It was Winnicott. I didn't even know where. I had to Google where Winnicott was.
I want to go golf this
It's just non-conference.
We could do this.
So, little a, remember, is the distance from the center to the edge. N is the number of sides. And then S is the side length. But remember, if we find one of those little pieces, we call it like X, and we have to double it to find S. So if I find only half of that little side length, I have to double it. So N's the number of sides, A is called that apothem, different distance from the center to the edge, and it's perpendicular. So A is always perpendicular to S. And the other formula we need in this section is when we need a central angle. Yeah, Jaden actually got the win in that game because we hadn't scored any runs, so we were down when he came in. So then he got the win for the. It also means Maddie gave up his first earned run all season. All right, so our central angle, our formula is 360 divided by n, and again, n is the number of sides. But a lot of times, remember, when we do that, we want to take half of it to find that little right angle. So if I enlarge this, when I come over here, this little angle is going to be half of y. So a lot of times when we find that central angle, we don't actually use that central angle, we use half of it, or we almost always don't. Okay. So we'll take a little break, again, whisper break. Why don't you guys, I don't know if we can do a quiet Kahoot.